Hello everyone, welcome to the electrical circuit simulation series. In this session, we'll study about the negative clamper using diode and capacitor. So this is the required circuit diagram. The components, the AC source, the second component is the capacitor, 10 microfarad capacitor. Then we have the diode. The diode is connected in such a way that the P is connected to the capacitor and N is connected to the ground. Then we have the resistor, 100 ohm resistor, where we get the output, and finally the ground to complete the circuit. So this is the input signal. The sine wave is our input signal. Let us see the working, what happens during the positive half. Now during the positive half, as the positive half passes through the circuit, the diode is on because the diode comes in forward bias. Now diode is working in forward bias when the positive cycle arrives. Now because the diode is on, so the current flows through the capacitor and capacitor also gets charged. Now this is the polarity of the charging of the capacitor. Positive side, positive charges on the towards the source, and negative charges towards the capacitor, towards the diode. So this is what happens, and then we get the output because the diode is conducting. We get the output across the resistor. That is we get the output. Now what happens during the negative half? During the negative half, the capacitor was already charged during the previous positive half. So when negative half appears, the diode is in off state because the diode is now in reverse bias mode. Now because the diode is reverse bias, it does not conduct. So now the charges which are there in the capacitor, they will discharge, okay, and they will flow through the resistor, and because of which we get some negative voltage. So these charges which are stored previously in the capacitor, they will add some negative DC voltage, and because of which what will happen, the output, we are getting the output, but it will also contain some negative DC components. Therefore this, as we can see, that this wave comes down. So what this negative clamper does is that it adds a DC component, a negative DC component, so that whatever wave we are getting, it just shifts towards the negative side. So this is the waveform, this is the input, and this is the output. So this negative clamper, it adds a DC component in the negative axis, so that the wave, we get the same wave, but it shifts towards the negative side. So this is the regarding the working of the negative clamper. Now let us see the simulation part. So now we are into the SimulIDE. Let us select the source. This is the AC source. Then we need a capacitor. So this is the capacitor here. We keep it here. Then we require a diode. This is the diode. So we rotate it, okay, in this way, and then we need a resistor. The resistor. Then we need a grounds. Keep it here. Now we do the connection. So this is the connection: capacitor, then the diode, and then the ground. Next we connect the resistor, where we get the output. Now in this particular case, the capacitor will always be connected to the circuit. So we want to see the clamping action. So what we do, we connect a switch here, so that we know that how the output is getting clamped. So this clamping is done because of the capacitor action. So we'll just put it here. Now what will happen in this, why we connect in this, is that suppose if now this switch is open, so this is closed and this is open. So when the switch is open, the capacitor will be the part of the circuit, it is connected into the circuit, and we will see the clamping action. But if we press this switch, so when the switch is closed, so the current will flow through this short path, and the capacitor will be as good as it is not connected in the circuit. So we'll see both the cases so that we can understand the clamping action. Now in the explanation part, I have not shown this because it was not required, but here we want to see the output, therefore we are doing this. Let us select the oscilloscope. So we just need to see only one wave, so I'll just connect this here, This is how we connect this. Okay, now I turn it on and start the power supply. So here we are. Okay, we get this. I just expand this, so we are getting this. Now here, as we know, as we see, we find nothing new. Okay, so what we do is when we just close the switch, now because of the closing of the switch, this capacitor is not connected, so this is output what we are getting. Okay, I'll just shift this time division. Okay, so we are getting this wave. Now suppose if I put the capacitor into the circuit by opening this, so the wave shifts down, as we can see. So this is the clamping action. So again, let us see this. So this is without the capacitor action, so this is the output is not clamped. We are getting the same as the input, and this is the baseline. As you can see, this is the baseline. So when we open this switch, now capacitor is connected into the circuit, and this is the clamping action. As we can see, this is the baseline, this is shifted down. So this is how the clamper works. So that's all for this particular session. Thanks for watching.